So welcome to 8.2 writing formulas for ionic compounds. You should have a lovely little worksheet that looks like this one. In this chapter, because what it comes down to is a whole lot of practice writing formulas and naming compounds, you're given quite a few of these little worksheets. And again, the idea is you could just copy them off a friend, right? But you want to learn it, right? So the best way of doing this is to actually, you don't have to do them all, but make sure you can actually write formulas for ionic compounds. So we will come back to this page. I will do a few on the left side of the page from number 1 to 20, and then you get to turn in this side over here, right? We'll go from there. So let's just take a look at this title, Writing Formulas for Ionic Compounds. I don't think you should be starting with this worksheet. There's about 5 different things you should be doing before you get to this one. I'll name a couple of them: the PowerPoint on the chapter, the PowerPoint on the actual rules for naming, probably formulas 1, formulas 2, and formulas 3. And by that time, you should actually be ready to go. So hopefully, we'll see how that goes. Just trying to get a pen working here. So I'm thinking that we should probably go back to a periodic table and show you just what it is we mean by a ionic compound. So all of the compounds you're going to be dealing with in grade 9 are binary ionic compounds. So binary just means 2 elements. That means you're taking an element from this side of the table, which are the metals, right? And combining it with something from this side of the table, which are, as they say, the non-metals. So these, just in case you noticed or haven't noticed, these are the positive ions. The reason these are positive is they all have, in this case, 1 electron in their outer shell that they're quite happy to get rid of. If they get rid of it, they become a positive ion. Where do you think that positive ion goes? Probably to something like these guys, the halogens, that really, really, really want 1 more electron in their outer shell so that they have a complete octet like the noble gases. So notice that the halogens are all -1, -1 for chlorine, -1 for bromine. So binary ionic compounds are just compounds formed between a metal, a positive ion, and a non-metal, a negative ion. So that actually, when I say a compound, they're held together by what we call an ionic bond. Again, another reason that I don't think you should probably start at this point is with the fact that you probably, if you're just starting with this, have no idea what we mean by polyatomic ions. These are ions formed by not necessarily single elements, but combinations of elements. So you're not going to see things like hydroxide on the periodic table, and so you're going to have to use a table like this table of polyatomic ions. And again, it's like your periodic table. You're always going to be given this on a test. Some of these questions, by the way, presume that you have access to a table that is complete. Some of the ones that were missing, by the way, on the negative ion side were C2O4, and this has a charge of -2, and that's called oxalate. So if you ever have to name something oxalate, then that's the polyatomic ion you're looking for. Sometimes you're asked to form a compound with the cyanide ion. This is the cyanide ion, Cn-1. By the way, that equals that. So you can either do it with just a minus sign or you can write it -1. The point is, both of them are cyanide. Cyanide is not good for you. So let's just look at the actual rules for naming these compounds. I think the best place to go is not there. Let's go here. So these are the rules course, this is elaborated on much further in the PowerPoint, but rule number 1, if I ask you, for instance, to predict the formula for a compound of, let's say, calcium and, what do you think, chlorine. So I give you the names of 2 elements, and then I say, write the formula. So represent each kind of element in the compound with the correct symbol. I know right off the bat, symbol for calcium, Ca. Symbol for chlorine, Cl. Use subscripts to indicate the number of atoms of each element in the compound. If there is only 1 atom of a particular element, no subscript is used. In other words, you're never going to see Ca1 or Cl1. If there is only 1 atom or ion of it in a compound, then you don't actually have to say it. So when we write the formula, we write the element that is more metallic, in other words, the positive ion first. Look on your periodic table. You're going to see that calcium is 2+, chlorine is -1. And again, you can figure this out just by looking at the periodic table in terms of how many electrons they give up or gain. But hey, in this course, you can just look it up. And this is where number 4 becomes really important. The algebraic sum of the charges in the compound must equal 0. 2 and -1, do they add up to 0? What if we had 2 chloride ions? Then it would be 2 times -1 minus 2 for a charge of chlorine, and that would perfectly balance the 2+ on calcium. So therefore, the formula for calcium and chlorine coming together is Ca. Cl subscript 2. Make sure your subscripts, by the way, are down below the line. If you put it up here, they're going to be confused with the actual charges. In a formula, you will never actually show these in your final answer. These charges are only there to help you come up with this formula over here. Right. I think I want to erase that, So let's see what happens if I go like this. I think if I go like this, it will take forever. Maybe we can find something called a hard eraser. Yes. Okay. Not bad, not bad. I'm thinking we should do another one. And again, the hardest part for most people here is just making sure that the charges actually add up to 0. And again, you're doing that by adding subscripts, right? So let's come up with a new one. Let's go for, how about a compound of potassium? Whoa, I think we need a color here, right? Let's go to potassium and oxygen. So what if I'd said oxygen and potassium? Would you put oxygen first? No, because of rule number 3, you got to make sure that the more metallic the positive ion comes first. By the way, if you are somebody who is more visually oriented here, I wish I was an artist, but basically these combining capacities, you can just look up on the periodic table that potassium is 1+ and oxygen is 2-. That doesn't add up to 0. But if you prefer, then think of it this way. Oxygen, let's start with potassium. Let's make potassium a lovely little girl. Okay, this is her eye, and you're right, I cannot draw. But this is potassium, so we're going to call her K. And she has a combined capacity of 1+, which means she is blessed with 1 hand. Oh, sweet. We might even give her legs, but let's not confuse the legs with the hands. The point is, in writing formulas, everybody's got to be shaking hands and have every hand full. So if we draw oxygen as some dude here, right? Wish I could draw. Yep. So this is oxygen. And oxygen has 2 hands. Boom. So, I don't think everybody's happy here. Oxygen has 2 hands, and he needs to be holding hands with everybody, right? So the only way you can have oxygen and his hands full is to draw 2 potassiums. And do you think I can actually duplicate this beautiful young lady? Not a chance, but we're going to try. So there's K again. She's got another hand, and now they're joined, and we know that the formula is K2O. And most of you are shaking your head saying, what kind of nonsense is that? Right. So let's go back to our sweet little heart eraser, and let's make it disappear because that was simply ugly. Okay, I think what we should do here is just consider what happens if you take a look at that actual worksheet, which means I don't really need to be doing all this erasing, except, like I said, there are these things called polyatomic ions, and polyatomic ions could cause you a little bit of difficulty. So let's find one that has a polyatomic ion. I'm looking here for something. Okay, here we go. Nasty Teacher says, give me the formula for a compound formed between sodium and hydroxide. Okay, first off, you notice immediately there's no hydroxide on the periodic table. So where in the heck is hydroxide? What you're supposed to conclude is that hydroxide must be a polyatomic ion. You would go to your wonderful little chart of polyatomic ions and you would see hydroxide, right? Hydroxide has a charge of -1. So then we can go back and write the symbols first. Na +1 and hydroxide OH -1. Make the more metallic first. Na OH. Guess what? +1 plus -1 equals 0. They balance. That is the correct formula for sodium hydroxide. Okay, I think we should do a harder one because that one was simply too easy, and we don't want to give you the false impression that, you know, these are all just immediate. Chances are you got to play with them a bit. The cool thing about this kind of chemistry is that they're self-checking. If you can look at your formula at the end and it adds up to 0, you have the correct answer. So you really don't have an excuse for getting them wrong, as long as you understand the principle that the positive ion plus the negative ion must equal 0. So sometimes you have more than one, more than the other. Okay, this time, let's go back to black. And we're going to form a compound between calcium. Honest. Come on, people. Calcium. And let's see now, nitrate. So again, first thing you notice, calcium's on the periodic table. You can get the charge of that one, but nitrate's not on the periodic table. So where in the heck do I get that? Let me show you where the heck. We are going to get it right there. Nitrate. Do you see nitrate anywhere? It's a negative ion. I think I can find it there. Nitrate is the name. NO3 -1 is its charge. So let's go back to this. Calcium and nitrate. Calcium is +2 and nitrate is NO3. We said it was -1, I think. Shoot, I gotta go check that again because that's causing me pain. It would be a real shame if we got it wrong. Yes, -1. So here we go. Notice that they do not add up to 0. 2 plus -1 doesn't add up to 0, but it would come up to 0 if we had 2 nitrates. So I'm going to tell you what most people do here that is wrong. Some people, thinking correctly, that you need 2 nitrates, write a formula like this with the most positive ion first, calcium, that's correct, and then nitrate, we said we needed 2, so let's just put a 2 down there. That is not good, because what you have now done is say there are 32 atoms of oxygen, and that is changing the formula of nitrate. So you can never, never, never change the formula of a polyatomic ion. Whatever it is on that chart, you have to use it the way it is. So the correct response here is to take the calcium and the nitrate, which is NO3, and then say to yourself, I need 2 nitrates. So how do I get 2 nitrates? Put it in brackets. 2 times nitrate, and nitrate is -1, so you got 2 times -1 is -2, which balances the +2. You are getting excited by this, right? Okay, I'm going to do one more before I actually get to that sheet, and if you can get this one correct, and by the way, don't hesitate to actually, stop the video. I know that sounds absurd, but you can actually, pause that Stevenson guy and then come back to it. I would recommend you try this. If you can get this one right, then there is absolutely nothing on that worksheet that can cause you the slightest bit of problem. Oh well, there is actually something, but we'll get to that in a second. So I am going to give you the name of 2 things that make up a compound, and you give me the formula. So here we go. I'm thinking we should write a compound between phosphate and ammonium. Like that word. Ammonium. Can you say ammonium? Sure. Okay. Just like the rules before, you are going to have to give the formulas for these first. So, I'm thinking that phosphate, if I look on my table or my ion chart, and again, you should have one of these, phosphate is PO4 with a charge of -3. So, PO4 -3. Careful, by the way, that you use the actual symbols, like don't write PO4, because that would be the symbol for polonium. This is phosphate, polyatomic ion, right? So that's phosphate. What about ammonium? Where is ammonium? It's not on the periodic table, so it has to be a polyatomic ion. Ammonium is your only positive polyatomic ion. So it's NH4 and it's +1. Whoa, you have to fix this on your sheet if yours is a misprint, because it's actually not NH4+. It's nitrogen with 4 atoms of hydrogen and a charge of +1. There you go. So let's go back, and I promise we'll get to that worksheet in 30 seconds. So we said that ammonium was NH4 +1. Okay, rule number 3 says write the element for the more metallic element first, the positive ion. So if you were tempted to go PO4 NH4, you're wrong. You got to put the positive ion first and the negative ion second. So ammonium is going to come first, NH4. Okay, for now we're going to write +1 there. And the phosphate, PO4 -3, is going to come there. Then ask yourself, do those add up to 0? +1 and -3? Nah. What if you had 3 ammoniums? Yeah. So again, you need 3 ammoniums, so put it in brackets, NH4 3 PO4. And again, you're not showing these charges, you're just showing that you have 3 ammoniums. Each ammonium is +1, so 3 times +1 is +3. 1 phosphate, which is -3. 3 plus -3 equals 0. Correct. And now you are ready to show me that you know your stuff, right? So not that one, but this one. Not that one, but this one. There we go. So like I said, you only have to worry about the ones over on this side over here. I will do a few from this side, and yeah. And then, by the way, I'm not going to do them all. And I'm going to leave some on this side. If you want to practice, do a few and then show me, and I'll tell you whether you're correct. And I don't see the point of doing something if you actually know how to do it already, just for the sake of doing it, right? So do make sure you get some help if you do need that help, though. So the first case here is write the formula for zinc bromide, write the symbol down, zinc, write its charge, and again, zinc on my periodic table is +2. Bromine is -1. So what does that tell you? 2 plus -1 doesn't add up to 0. You need 2 bromines. 2 bromines means ZnBr2. Right. By the way, don't be freaked here by these endings, ide, bromide, oxide, fluoride. Anytime you have a binary ionic compound and you name it, you just change the negative ion to ide. So bromine becomes bromide, oxygen becomes oxide, hydride is hydrogen, nitride is nitrogen. It's just 2 elements. So sodium oxide, I'm going to start with the symbol for sodium, which is Na. It's +1. Oxygen is -2. And again, these are charges. I think we need 2 sodiums because 2 times +1 is +2, which is going to balance the -2. So the correct answer would be Na2O, right? Lithium hydroxide. Again, this is where you're going to use your periodic table. Lithium is +1. Hydroxide is on your table of polyatomic ions. It's -1. So the correct formula is just going to be LiOH. Piece of cake. Let's do something that's more challenging. The ones on the right-hand side of the page, you'll notice that the metal, this guy, has a Roman numeral beside it. That's because when you notice on your periodic table in the middle, you have some of these metals with more than 1 charge. I'll show you. So you see copper. Copper is 2+, copper is 1+. Nickel is 2+, nickel is 3+. So how do we tell the difference in a formula? They have to give you the charge in the brackets, right? So let's go back to this. Copper 2, all they're doing is telling you that the copper in this particular case that is being used is Cu2+. The chlorine, and again it's ide because there's just 2 elements, is Cl-1. I think we need 2 chlorines, right? 2 chlorines will balance the charge, so we write CuCl2. Iron 3 oxide. Again, if your heart is pounding here, you have no idea what you're doing, make sure you talk to me, get some help. But they're telling you that the metal has to be the iron with the combining capacity of 3+. Oxygen is always -2. So immediately you are going to come to some wonderful conclusion that, how do I make that plus that equal to 0? Well, it's like this. There is this thing called a crisscross method, by the way, and we'll get to it. You have one handout where it is introduced to you. I mean, there's always a way of doing this just by bringing down the 2 this way, bringing down the 3 this way. It's called the crisscross method, but you know what? It's actually better to think about it. You want this plus this to equal 0. So what if you had 2 irons? and 3 oxygens. And then you check it. So I'm saying 2 irons and 3 oxygens, and then take this subscript, multiply it by your charge. 2 times 3 is positive 6. 3 times negative 2 is negative 6. That equals 0. This is good. I think I'll do one more for you, and then if you need some help, hey, talk to me about it. We can help you out here. So in this particular case, the manganese that is being used is charged Mn2. So we write Mn2 plus, and then the nitrate is always -1, and again you get that from your table of polyatomic ions. So the only way you can make those two add up to 0 is if you've got 2 nitrates. So don't put a 2 here, because that would be wrong. That would be 32 nitrates. But what you can do is use brackets. So now it's Mn bracket nitrate, and you need 2 of them. And then check your answer. 2 times -1 is -2, which balances the +2. Correct. Good. Thank you for coming.